All right, so now we want to take a look at the addition rule of probability. And the first rule states that when two events A and B are mutually exclusive, the probability that A or B will occur is the sum of their respective probabilities, okay? So that is probability of A or B is equal to probability of A plus probability of B. And we know this from the third axiom, okay? Now, also, if we have a sequence of finite events and they are mutually exclusive, then the probability of their union is equal to the sum of their respective probabilities, okay, as defined in equation 3. And we can generalize equation 3, right? Once we generalize equation 3, we have it as defined in equation 4. So equation 4 is a generalization of what we have in equation 3, right? Now let's take a look at the second rule of the addition rule of probability. The second addition rule of probability states that if A and B are not mutually exclusive events, then the probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So here we are taking into consideration the probability that the two events occur simultaneously, okay? All right. Now, in general, if we have a sequence of finite events and they are not mutually exclusive, then we can express it as defined in the equation below, okay? There's a proof to this, but I'm going to skip this, okay? All right, so now let's quickly take an example. Example 1, a city has 9 insurance firms. 3 is stationed at the north, 2 is stationed at the east, and 4 is stationed at the west. If a person selects one insurance firm at random, we want to find the probability that it is either from the north or west, okay? So first of all, let M, E, and W denote the stations at the north, east, and west respectively, okay? All right, so we can basically put this in a table form. So this is similar to the empirical probability we look at from a previous tutorial. So you have the city, north, east, and west, and we have the corresponding frequency. So the number of stations at the north, we have 3, at the east 2, and the west is 4. So in total, we have 9 of them, okay? And our objective here is to find the probability that a station is either from the north or west, okay? Now we can see from here that a station that is stationed at um, an FM station that is stationed at the north can never be um, in the east or in the west, okay? So these are mutually exclusive events, okay? So the probability that a station is either from the north or west can be expressed in this form, probability of the north plus probability of the west, okay? And we can define it in this form. So the probability that a station is located or a station at the north is going to be what, 3 out of the total 9. And the probability that a station is from the west is 4 out of the total 9. So in all, we are going to have 7 out of 9. Okay, you can also leave your final answer in decimal if you wish to. Okay, all right. So this will be the solution for example 1. Let's take a look at the second example. In a hospital unit, there are 8 nurses and 5 doctors. 7 nurses and 3 doctors are females. If a staff person is selected, you want to find the probability that the person is a nurse or a male. Okay, so let's look at the solution. Let N, D denote the nurses and doctors respectively. Also let M and F denote the males and females respectively, okay? So in order to do this, let's try and create a table. So we have the nurses and doctors at the column side and the gender at the row side, male and female, okay? So from the question, let me take a look. We are told that there are 8 nurses and 5 doctors, okay? So we have the total number of nurses is 8 and that of doctors is 5, okay? And from the same question, we are also told that 7 nurses and 3 of the doctors are females, okay? So we have the female nurses are 7 and that of the female doctors are 3, okay? So if this must sum up to 8 and 7 of them are females, and 7 of the nurses are females, then automatically one of them should be a male. And for the doctors, if there are 5 and 3 of them are females, then we have 2 of them to be males, okay? So we can give the totals now. So once you sum this, get 3, sum this, get 10. So The column should correspond to the row side, row total. We have 13 of them, okay? All right, so our objective here is to find the probability that the person is a nurse or a male, okay? So, and here you can see that the probability that the person selected is a nurse or a male can also occur at the same time. So we have the intersection here. We have the probability that the person can be a nurse at the same time is male, okay? So the probability that a staff person selected is a nurse or a male can be expressed in this form. So we have the probability that the person is a nurse, probability that the person is a male, minus the probability that the person is a nurse and a male, okay? So this is the general rule of addition rule of probability. So the probability that the person is a nurse is 8 out of 13, so the number of nurses, right? And the probability that the person is a male is 3 out of the total 13, minus probability that the person is a nurse and a male, okay? So here, it's 1 out of 30. So once we sum this and you subtract this, you obtain 10 out of 13, okay? So you can also leave your solution in the decimal form if you wish to. All right, so this is a trial question. I'm going to leave the solution in the description of this video so you can check it out. Don't forget to subscribe if you have not, and thank you for watching.